Okay. Multiplication of fractions. So we know what fractions are. A fraction is an equal part of a whole. That's our most common definition. We have other ones, like a division problem or a ratio, for example, or a point on a number line. But we're going to go with a fraction is some equal parts of a whole. Now I need you to think back to last quarter when we had different physical models for what it meant to multiply whole numbers. And we want to see if we can apply any of those models here. So what did we take multiplication to mean? So if I write 2 times 3 and some kid has never seen that before, how would I explain that to a kid?
Groups of sets.
Groups of, yeah. So multiplication means groups of. That's one example. So I'm going to try that with fractions and see if I can do that. So suppose I had 2 is a fraction, right?
Over 1, yeah.
Yeah, because that's 2 over 1. So 2 times 1/3 would mean 2 groups of 1/3. I can do that, right? Here's a group of 1/3 here. And here's another group with a 1/3 in it. And all together, I think when I put that together, I get 2/3. That's not bad. We can do that. Now, multiplication is supposed to be commutative, which means I should be able to switch it, and it'll still make sense and give me the same answer. So if I switch it, let's see, 1/3 times 2 means 1/3 groups of 2. Oh, that doesn't make as much sense to my brain as the other one. How about you guys? 1/3 groups of 2. Okay, let's see if we can draw a picture of it. What am I taking 1/3 groups of?
Circle?
Oh. Sure, we could do circles. Or
Is that what you're asking?
well, we're taking 1/3 groups of 2, right? So the 2 is important. What do we know what 2 looks like?
2 circles.
I prefer squares, so you can do circles. You can do circles. They're harder to draw for me. Squares, I'm pretty good at some days. Circles, I'm not good at most days. So that's 2 right there. Can you think of a way to take 1/3 of that group of 2?
Split them into 3 pieces?
Sure. Let's just take a big old knife and go thirds. Bang. Now that's 3/3. I only want one of them, like this top group right here. So is that right there 1/3 groups of 2? It is. I started with 2. I took 1/3 of those 2. And what's the shaded part? Well, how would you describe that if you put it together? I have these 2 pieces. Do they make a whole?
No.
No. What part of a whole do these 2 make? Yeah. 3 pieces of that same size make a whole, so my answer must be 2/3. Oh, so we can do it. We got to be a little tricky about it. We'll do more examples of this in a minute.
The only thing like I would find confusing, and I think it's just because I'm overthinking it, since you're drawing like 2 separate squares,
Yep.
you would think that it'd be like the 2, 6.
Yeah. Okay, what's a whole here?
3.
Well, a whole is 1 square. So maybe I should have a note that says, because if I'm saying that's 2, the first thing I drew, then this must be one whole. And what's a fraction? Equal parts of a whole, right? So I can't answer fraction questions if I don't identify what a whole is. So we have to have that in mind. If we don't know what a whole is, we can't answer the questions. So was that a little weird? Yes, it was a little weird.
Wouldn't it have also been okay to make them so they're the same denominator and do it that way? So
let's
instead of
see.
2 over 1.
I'm going to come back to that question. So about the same denominator. Just hang on a second. So let's go back here. Were we able to do this really easy without thinking about denominators? Pretty much. I mean, I had to draw what 1/3 looked like, but otherwise I really didn't have to think about different denominators. So should we stick with groups of for a minute? Sure, let's do it. Let's do a harder problem with groups of, and then I'll give you what I think is an easier option. That slide is in the wrong spot, and so is that one.
You're going backwards.
No, I think I put a slide in the wrong spot. Give me 1 sec to reposition slides here fast. Multiplication. So you go at the end, and you go after that, and then things are in order. Okay, new page. Let's try a harder one. Let's try 1/3 times 1/2, which I would interpret to mean what is 1/3 groups of 1/2. So when I read that sentence, okay, what is 1/3 groups of 1/2? I have to find 1/3 groups of the half. I think I kind of have to know what 1/2 is first before I can deal with the 1/3 of it. So draw a picture of a half. So I think I need to draw 1/2 first. Draw a hole, and again, I like squares. If you like circles or hexagons, feel free to use those. We will try hexagons in a minute. And 1/2. Boom. There's 1/2. Okay. Now I need to take 1/3 of that group of 1/2. Can we do that? How? What should I do? Cut it into thirds now, right? Oops, arrow there. There we go. Let's cut into thirds. And I'm going to do the way I did it before. I'm going to cut the other way because it feels good. So I'm going to take that piece I just had. It was halved, and now I'm going to third it. And although I started with that half, I now want to only look at 1/3 of that half, which is just that piece right there, is 1/3 of that half. So 1/3 of a half is what part of a whole?
A 6.
1/6 of a whole. Yeah, that's what this picture is leading me to believe. 1/3 of 1/2 is 1/6 of a whole. Okay. Yep.
So let's say for those who are like, I struggle with like drawing this out.
Yeah.
I'm good with like the math fractions. I know that's 1/6.
Okay. Why is it 1/6? Because someone
I'm
told
doing-
you.
no, the
Someone told you
arrows.
that you have to multiply the numerators and denominators. Okay.
Yeah.
Why do you have to multiply the numerators and the denominators separately to get an answer? Why? Well, because my teacher said so. Why? Why did they tell you to do that?
That's how it's done.
Why? Why does it have to be done that way? I don't like it.
No, I was gonna ask if
Right? Why do we have to have a common denominator when we add fractions? Well, because I said so, or what does it mean to add? It means to combine and count, but we can only count like things. And they're not like if they have different denominators, which means we have to have a common denominator. Okay, What does it mean to multiply fractions? Well, it means to look for groups of. And because we're looking for groups of, coincidentally, it turns out that finding groups of means just multiply the numerators and just multiply the denominators. That's why. Okay, so you have down how. I know you do, all of you. What my big point in this class is, why the hell do we do it that way in the first place? And it all boils down to, what does multiplication mean? That dictates why we have to do it that way. Do we have to find a common denominator with multiplication? We didn't, did we? Did we have to with addition and subtraction? Yes, we did. So why? Well, because that's what it meant to add, and this is what it means to multiply. All right. Now, we did have other definitions for multiplications besides groups of. Can anybody remember any of the other definitions we had last quarter? Besides groups of. 2 groups of 3 was a great one. 2 kids, they each got 3 apples. But there are other examples of multiplication in the world around us that aren't that. Repeated addition is one. Okay. So let's test that one out. Multiplication means to repeatedly add. So just a reminder, 2 times 3 means add 2 groups of 3. Okay, 3 plus 3 is 6. No problem. That works fine if I do something like 2 times 1/3, because that means add 2 groups of 1/3, which is 1/3 plus 1/3. And we know they have the same description, so I must have 2/3. But what if I try that with 1/2 times 1/3? Add 1/2 groups of 1/3. Wait a minute. How can I add less than one thing? Don't you need more than one thing to add? Yeah. Okay. I don't know what that means for addition. Okay, so repeated addition's too weird. What other methods did we have, or definitions for multiplication? Monica, what was it? Area, yes, that's my favorite. Multiplication is an area. Area is some base by some height. What's a fraction again?
Equal parts of a whole.
Equal parts of a whole. I'm just going to remind ourselves of that. Fraction. Because it doesn't matter if we know what the whole is. We can't find an answer if we don't. Okay, so we have to know what a whole looks like. So a fraction is some equal parts of a whole. Can you guys tell I like doing fractions? I think they're fun. Hopefully you all will later at some point in your life. All right, so let's see. Let's pick a problem. Like, we do it different than before, sure. Let's do 1/3 times 1/4. So if I say area is base times height, then that means I have to show a base of 1/3 that has a height of 1/4. And I can't show you what a third looks like unless I know what 1 whole looks like. Okay? So I'm just going to start by drawing this L shape here, representing my base and my height. And then I have to measure out some distance and say, hey, right there, that's 1. You pick what 1 is going to be. And then I should measure that same distance up and say the distance from here to here, that's 1 also. Once I do that, I can say, oh, well, if that's 1, then that's about 1/3 right there, to the best of my artistic ability. And if that's 1 up here, choose a different color, then 1/4. That looks about 4ths right there. This one right here would be about 1/4. So my answer should then be 1/3 over 1/4 up. That should be my answer right there. Okay, so that's a picture of the answer, but I need a number for that answer. And the question here is, well, what is a whole area? Well, wouldn't a whole area be 1 by 1? So this whole thing in green is 1 whole area. Area. And all right, what should I do? So, okay, mine's a small part of that whole area. Can I identify which small part that is? What should I do to figure it out? I think I should just draw in the thirds completely, and then draw in the fourths completely.
No, it's a pancake.
It's a
Cake.
It's a cake. Yeah, it turns out cakes are helpful in working with multiplication. So what part of a whole have I isolated as a third by a fourth? It's 1/12 of the whole, isn't it? It's 1 out of 12 equal-sized pieces.
Like, I know you have to, like, draw a picture to, like, describe it or whatever. Or could you really just multiply across to get your answer?
Okay, so that is an algorithm. It's not, why do you multiply across them? Okay, so I agree with what you're saying. You're saying 1 times 1 is equal to 1, 3 times 4 is equal to 12. Why are you allowed to do that? Because multiplication means area. Area is base times height, and a fraction is an equal part of a whole. That's why you get to do that. It's a coincidence. It just the arrows just happen to flow that way. How did the arrows flow for addition? Did they flow the same exact way? No. Why not?
You have to cross.
Because somebody said, oh, I think we should cross.
Is it because it's referring to different things, like different things and situations have different ways of answering the question?
Yeah, why? Because addition means combine like things. Does multiplication mean to combine like things?
Yeah.
No. In this case, multiplication means an area, a base by a height. Fraction is a part of a whole. When we take that area and we compare it to a whole, we find that, hey, look what way the arrows flow. Okay? So you were taught to do this, but you were never taught why you should do that. Why not? Okay, so here's a good question. Why doesn't multiplication work like this? Why isn't that multiplication? Why does it have to be going straight across? Because that doesn't work with what multiplication means as area. You won't get the right answer. Take some time to sink in. So we have two different ways to think about it. We have groups of, which is kind of like an area, and then we have the area. So we're going to give this a shot for some other problems, and then we're going to work our way up to mixed numbers, which again add a whole new bit of complication. So I added a new activity at the end of the fraction section about multiplying fractions. So we're going to look at physical models. To do this, we're going to need a couple of things. We're going to need some pattern blocks for the first part to show multiplication. We're going to use the group sub model, and then we're going to use paper and pencils to do the square cakes version of multiplying. Question?
Can we ask for turning this in?
Yes, this is going to be turned in. Yeah. And you don't have to have a printout of this, but I can make one for anyone that wants one. Anybody want a printout of this? I'll take one. Okay, just print a whole bunch. Because again, you have to draw this out, and the printout does not leave enough room for you to draw, so you need to draw this out on another piece of paper. And again, we'll first do it with pattern blocks, and then we're going to do it with square cakes. Let's hit the print button here. See how it looks. Scale it up a touch. scale. Why won't you blow up? Kidding me. So bizarre. Okay, it's not going to print quite right. Oh, I don't know why. We're just going to have to go for it. Pages 1 and 2. And we will print 10 copies. All right. So like the last activity we did, I do the first example for you. So let's just walk through that together. For the pattern blocks, part 1, we're going to let two hexagons be one hole. So we have a new definition of a hole. Can we do that? Yep, we can. Just like with the color rods, we can pick which color gets to be a hole. We can do the same thing with pattern blocks. So 2 hexagons is a hole. And what I want to demonstrate using the groups of model here is what is 1/3 of 3/4. Okay. So at first I state 1/3 times 3/4 up here. And then I start with one hole as 2 hexagons, and I want to find what is 1/3 of 3/4. And to do the groups of, you have to show the second number first. Okay? Because you can't find 1/3 of something if you don't know what it looks like. That make sense? So first thing I have to do is show what's 3/4. Okay, so show 3/4 with your pattern blocks. 2 hexagons is one hole. What does 3/4 look like?
75%.
Or yeah, 75%, right? Some kids are going to be down with that. So here's my one hole. And then I throw in my 3/4. Okay, so all right, I've got 3/4. I want to know what is 1/3 of these 3/4. Is that pretty easy to identify? Yeah, one of these is 3/4 of the whole. Okay. So I am going to just grab this into my board and show you what I would write down. You can kind of see on my paper, but how I would write it regularly. Screen shots. Page. All right, so this is again activity 5.3. This is part 1, number 1. I want to know what is 1/3 times 3/4, which means what is 1/3 of 3/4. And so first, we have to show 3/4. Second, we'll show 1/3 of the 3/4. Right there. That's 1/3 of 3/4. And then that yellow's not very good. Let's try green. 1/3 of 3/4. Now, that's just a picture of the answer. I have to use that to state the actual answer. Oops, 3. What part of a whole is that?
1/4.
Yeah, so what we've shown is that 1/3 of 3/4 is 1/4 of the whole. And we got it. So what I want you to do is try a similar procedure for those other 3 problems that come next, given that 2 hexagons are one whole. Grab your paper. So next is to draw a picture of 3/4 times 1/3. What is 3/4 groups of 1/3? part 2. So usually for the multiplication, it takes me 2 or 3 stages of drawings to illustrate what I'm doing. So you give that a shot and I'll show you what I would draw.
For these ones, we are still doing just shapes, right?
For the first part, we're just using pattern blocks. For the second part, we'll draw square cakes for part 2. And there's essentially 3 steps to illustrate multiplication with groups up.
Mm.
And again, I'd recommend using the physical toys to try this first and then try to draw it. Show what a hole is. Then try and show what 1/3 of that hole should look like. That turns out to be the trickier part here. Hint, 1/3 looks like a chevron. Does anybody not know what a chevron is? Okay, nobody seems to want to volunteer. So a chevron is a shape that looks like this. That's a chevron. It's kind of sideways. Usually it's oriented the other way. Let's see. Let me orient them the other way. Yeah. Anyone ever seen that shape before?
Yeah.
Military uniform, Chevron gas station. Yeah, so the word chevron, they stole that word. It means that shape right there. That is a chevron.
That's supposed to be 1/3.
My belief is that a chevron is 1/3 of that hole. I'm going to attempt to illustrate that here.
Oh, okay.
Come here. Wow, this tool is awkward some days. So I claim that that is 1/3. Let's see, which way do I want you to go? That way, maybe. Yep. There. Right. Ah, yes. All right, so if you look at the piece I have here, how many chevrons do you see in my second drawing there?
2, 3.
3. There's a blue one at the top, a yellow one in the middle, and a blue one at the bottom, and they are all exactly the same size. So a chevron, which happens to be 2 rhombuses, is 1/3. So if I remove the second chevron I drew, that second picture is a picture of 1/3. Oops. So first I show 1/3, got it. Now I have to show what is 3/4 of that. So second, let's go green. What is 3/4 of that 1/3? Uh-oh, what do I have to do to those rhombuses? Change them to the green pieces. Yeah, so I'm going to go back to my toy and trade in these guys for some triangles. So I really do believe it's important to hold these physical things in your hand to play around when you're new at this. Don't just start trying to draw it out. Okay. So that is still 1/3. And then, let's see, 3/4 of that would be this one here, and that one there. So this region right here meets that 3/4 of a third. Third step, what part of the whole is that? Did I just circle? 3/12 is one answer, okay. 3/12 of a whole. Does anybody see a different answer? Not half. What shape did I just make that I circled? Not a rhombus. The rhombus is the blue shape.
Oh, the
Trapezoid.
The trapezoid. Yeah, 3 of them make a trapezoid. And a trapezoid is what part of the whole? A fourth. Yeah, so another answer, if you redraw the picture again, 1/4 of the whole. Okay, so I'm going to add to my picture one more time because I can reduce it. Oh, whoa, how did that happen? Weird. I just want to move you, please. Uh-oh, my app is troubled. Oh. Clear. Oh, really? Oh, either I broke it or my pen doesn't work very well. Last try and then I give up. Whoa, okay, my app is broken or my pen is broken or something. Weird. Goodbye. All right, questions on that one?
It's 1/4.
The answer is 1/4, yeah. So 3/4 times 1/3 is 1/4 of a whole. All right, try that for the next ones. I'm gonna let you guys work on your own for a little bit. This is hard, it takes practice. It should stretch your brain, which means it's gonna hurt a little. So,
Where did this number come from? Like when you're doing your problem, the 3/4.
okay, so here we want, did you write down what we're trying to do? So I want to take one, oh no, you wrote that. Oh, you didn't write this. Yeah, so the first thing I did here was write what that means. What does that mean?
So what is 3/4 of 1/3?
1/3. Write that first. Yeah, so that's the first thing I wrote. What question does the problem ask in this situation? So in this situation, it says, what is 3/4 of 1/3? Okay, so I can't find 3/4 of something until I know what it is.
1/3.
So we have to show what 1/3 is, which you did. Once we do that, so that's stage 2. Stage 3 is to identify what is 3/4 of that 1/3.
Okay.
And then the last stage is what part of the whole did you end up with?
Okay.
Yeah, so see how I broke mine into different parts? I had to first state the question. Once I have the question, I show the second number.
Okay.
So then I can take part of it,
Part of that. just
and
all-
then I got to identify that part I grabbed is what part of the whole.
Yeah, you're okay.
So that's the process in trying to figure out what it means.
Okay.
if we use groups of as the definition of manifestation. All right, so try that for the next pair of fractions. And to do this, you're going to have to draw at least 2 pictures, sometimes 3 or 4 pictures to get your point across. And think about playing with the toys. How often do you have to change your picture when you're playing with the toys? Every time you make a change, that means you have a new step in your process. So next we have 5/6 of 1/2.
Start like this. Because it's your goal, right? Right? And from there, we can change to a little more.
And then we have to make sure.
Well, I did what is best in someone else. So then from the top, you use the triangle through.
Like that. But this is your line.
So then it'd be like that. And that's half of your hole.
Yeah.
And then from there, you're finding out.
But this is
5/6 of
yeah.
that.
No, I understand.
After 12 total. Because you're only looking for half.
So for that last part, for this
Right.
one,
But then you're gonna do.
you have to make the other
So
half
then
then
you have to make it smaller.
to match to get the,
And then go with 5/6
to
and
get
1/2.
part of it was the
Only one of these is a half, one more.
Do we have to keep drawing this other half here?
Yeah, to show
Because
that.
that 2 of them is a whole. I gotta
Yeah.
keep drawing.
So like,
So the first time I draw it, I draw what half of a whole looks like.
yeah,
So
I
that's
have
what-
that.
Then I try to show, okay, what's 5/6 of that half?
I have that.
Okay, there's 6 pieces, I counted 5 of them, right? So then I need to know what part of a whole is that? Well, so I just took those 5 pieces. What part of the whole have I shaded? If I cut up the rest of this, just like I did above,
Right.
how many pieces are there in a whole?
12.
12, and how many do I have shaded?
5.
5. So this is 5/6, or 5/12, excuse me, of the whole. So that's my final answer.
So, yeah, so what I'm asking is, in order to keep like showing the next step, I do have to draw like the whole what the whole is made of the parts. So
You have to draw.
because I only
the
have,
whole.
I don't know if that makes sense. Like here, I only have the up to the second part.
Yeah, so then you need to draw one more picture showing only those 5.
Okay, without the other half.
I still need the other half here. I have to, out of the whole, just draw those 5 pieces. So notice my second piece. So notice this piece down here is shaded green,
Mhm,
but it's not shaded over there
mhm.
because I'm trying to show what the final answer is. Then you want to do this again for what is 1/4 of 2/3, and then comes the square cake part. Jimmy, you got to leave in a few minutes? Yeah. Okay. So if everyone could take a break from whatever they're doing, I just want to go over the part 2 because Jimmy's got to leave a minute early. So here's, the next part is going to be the area model. Now, personally, I think the area model is easier for me, but everybody's brain is different. In my past experience with teaching people what fraction stuff means, like multiplication, I found most of my students playing with the hexagons hurts their brains a little bit. But part of what I'm trying to do here is help you grow your thought process about fractions. And the more varied experiences you have, the better. So even if this part hurts, bear with me for now. I know it hurts. So here we're switching bases. We're not saying groups of is what multiplication means. We're saying an area is what multiplication means. And I probably should be a little more precise here by saying area is base times height, like I did before. I'm just going to add that here. So area equals some base times some height. So then draw your best square. And in this case, I want to show a base of 1/5. Now, in order for me to show 1/5, I first have to show what one whole is, and then break that whole into fifths and indicate where that 1/5 is. My height is going to be 1/3. Now, I think squares is the best way to do this. So whatever length you pick to be 1 across the base, try to replicate that length vertically. And I've always found, as much as I draw these sketches, is making a length one direction, it's hard to make exactly the same length in a different direction. I don't know if you guys have that same experience. So usually I pull out something like my finger or a pencil and try and estimate where it is. So first identify where 1 is going up, and then cut it into, in this case, thirds. Now, the first time I drew this, I picked the 1/3 at the bottom. Here, I'm picking it at the top. It doesn't matter which way you go there. So here, I'm saying this is the third I'm going to choose. And my answer is where the 5th and the 1/3 overlap. So that's my answer. Now, what is a fraction? Equal part of the whole, right? So I can't tell you what that rectangle means until I can show you what 1 whole means. Do I have a picture of 1 whole here? Answer is yeah, this 1 by 1 square, that's my 1 whole. And since I drew all my other fifths and thirds in, I can see that there seem to be 15 equal pieces in a whole. So that leads me to believe that a region that is 1/5 by 1/3 is 1/15 of the whole. And so the 1/15, that's my answer. So this is kind of a three-stage process too. I got to draw in my base, I got to draw in my height, and I have to establish what a hole is. Once I do that, I can count out what the answer is. Now, I picked pretty simple fractions here, 1/3 times 1/5. Once the fractions have more pieces, or if they become improper, or if they become mixed numbers, it gets harder. And I have some examples later that we're going to try in the last two examples of mixed numbers and fractions. So if you would skip down to number 4 on the second page. So this is part 2, number 4. It says on the computer I was trying to type 1 1/2 by 1/3, but I was using the slash, so it looks a little weird. What's my base here? I always choose the first number as the base. So I would have to draw a base of 1 1/2 and a height of 1/3 and try and find the answer based on what one hole looks like. So just a rough sketch of that, and I'll let you guys finish it. Usually when I do these area problems, I make myself just an L shape. I usually do the base first, but you don't have to. I decide what is 1. Since I have a mixed number here or an improper fraction, I have to show farther than that. So in this case, 2 is sufficient because I need to be able to identify what 1 1/2 is. And I usually draw in all the intermediate ones. So I'm going to draw 1/2 and 1 1/2 in. Then I try to measure that same 1 distance upward. I think that's going to be about there. And then I have to split that into thirds, which is probably about right there. And maybe I'll pick this down there to be my 1/3. So my answer is this rectangle right here, but I got to figure out what part of a hole that is. So I'm going to leave you to try and finish that part, and then I'm just going to walk around and help. Summer, if you have a question, just chime in with your mic or with a text. If you're stuck on something, check with a neighbor or ask me. Why am I going up to 2?
No, I was asking him the way he drew his picture.
Yeah, so for my shaded area, I definitely want to stop at a 1/2. But often when I do these, I mean, I need to know what one hole is, but I usually continue it out and kind of draw the whole thing in. And then cut my pieces. And there's several ways to turn this into an answer. What's a fraction mean? Equal parts of a whole, right? How many parts do I have shaded?
3, 12,
3. And how many are in a hole?
12.
No, there aren't 12 in a hole.
6.
Yeah, remember a hole is 1 by 1. There's 6. So the answer here should be 3/6. Oh wait, 3/6 is really a half. So there should be a way for you to show with a picture that it's also 1/2. Yeah, so 3/6 is one answer. You have to kind of redraw to get a half out of it. I'll fill in some more work there in a minute.
I got lost. When did you cut them or why?
The red lines I drew?
Yeah,
So
I got lost there.
let's back up a ways. Let's see. All right, right to there. So for me to do this, let's see, there's supposed to be a laser. Get that to work. There we go. So I had to identify where 1 was, right? And then my number though was beyond 1, so I had to show 2 so I could accurately find 1/2, right? So I attempted to make this the same length as that right there. Right? So now I can pinpoint where 1 1/2 is. Then I have to make that same 1 go vertical so that I could cut it into thirds. So I had to mark a third there and a third there. Now, usually what I do from there is I draw the whole big grid and I draw all my division lines right away and then shade the piece I want.
So division lines mean like in this case.
Division line means halves and thirds. So how to halves cut this up and how to thirds cut this up. So I'm just going to start this picture over again just for fun. Oops, I want to use red, blue. Ruler here. So let's say that is 1, and that is 2, and that's a half, and that's a half. Now I'm going to go up the other way, drop my ruler. So then that's 1 there. And we'll do it. I have to guess that where a third is, there and there. So once I make my measurements, usually what I do is I mark off a bunch of holes that encase my answer. So to encase my answer, I'm going to go 2 holes horizontally and 1 hole vertically. And I'm going to cut all of the thirds in that direction, and I'm going to finish cutting halves in that direction. And I like to use colors to code it, right? So the blue square is my hole. I have 2 holes there. All the reds are my parts of a hole. And then what's my answer? Well, my answer is whatever 1 1/2 by 1/3 is. So this is my answer here, right? And so a quick answer for this right here, 1 1/2 times 1/3, is to just go by what a fraction means. And a fraction means equal parts of a whole. How many parts are there? There are 3 parts. How many pieces are in a whole? There are 6. So quick, I get 3/6 as the answer. Okay. Next thing I usually do is try to redraw that into a single whole. Or if it's a improper or mixed number, improper, I put it into multiple ones. So halves that way, thirds that way. And you have 2 options here. You can throw those pieces anywhere you want. They don't have to go in the same spot. So you could throw them there, there, and there. That would be one version of the answer. Would most people be able to look at that and say, hey, you shaded half of that square? Don't you see 2 L shapes that look the same size? Yeah. But I didn't have to put them in that way. I could have put them in this way. When I put it back together, I can do it any way I want.
Can you talk about number 2 with the area? I'm dull for time.
The 1/2 by the 2/3?
Yeah.
Yeah. So let's see, that was number 4. Let's add a new page here. Uh-oh, Jim, you're late. So part 2, number 2, you can tell your teacher it's my fault. Who's your teacher?
Mr. Richardson?
Phil?
Yeah.
Oh, good. Okay. You can tell him it's my fault. All right, so 1/2 by 2/3, right? All right, so I'm going to let the 1/2 be my base, 2/3 be my height. So then, like I said, usually I like to draw my L shape first, decide where 1 is. I'm going to use my ruler. So 1 is going to be there. And same one over here. Okay, so then I want half this way and thirds this way. And sometimes I get those right the first try, sometimes I gotta race and try again. All right, and then I'm curious about 1/2 and I'm curious about 2/3. So then what I do is I fill in this case, 1 hole will do it. And then I cut my half and I cut my thirds. And then I shade my base and the height that I want. And I want this half by those 2/3. So this is my answer.
Okay, that's what I thought. That's what I thought.
So
It
the
just doesn't look
first,
right to me.
yeah, so the first shot at the answer is to say, okay, there's 2 pieces and there's 6 in a hole. So I get 2 6 as one answer.
And now I am right back to work.
Okay. But what could I do with this one?
You can turn it into 1/3.
Yeah, and to do that, what I do in my picture is I can find groups of 2. So for example, switch colors. There's one group of 2 there, another group of 2 there, and another group of 2 there. So when I do that, I get 1/3 as another answer. Should I miss their social media?
Oh, yeah. I do have a question though. I mean, do you have this one and that one?
I should have an extra copy. See you later, Josie. Here's 5-2.
Do you have your stapler?
Oh, yeah, over here. All right, stop the recording, but Summer, I'm still online if you have any questions.